Welcome, everyone, to this explainer. We hear the word cloudburst thrown around in the news all the time, right? Well, today we're going to comprehensively unpack the whole shebang. We'll explore the literal mechanics of what's happening up in the sky. We'll look at why it's so incredibly difficult for our meteorologists to actually predict them. And finally, we'll dive into the socio-political implications of how this buzzword gets used right here on the ground. Because the reality of these events is frankly absolutely devastating. Imagine a sudden, literal wall of water crashing down from the sky. It can sweep away entire homes and roads in a matter of minutes, leaving behind nothing but scattered debris, like the aftermath of the flash floods in Pahalgam. It's a terrifying, overwhelming force of nature. But what exactly is happening up there to cause this? Okay, let's dive into this. Here is our roadmap. First, defining the cloudburst. Second, the anatomy of a cloudburst. Third, the forecasting challenge. Fourth, improving future predictions. And finally, the accountability blame game. Section 1, defining the cloudburst. So before we get into how they actually form, we really need to establish the exact meteorological thresholds, because a cloudburst isn't just a heavy rainstorm. Officially, according to the India Meteorological Department, or the IMD, it all hinges on the number 10. We're talking 10 centimeters or more of rain in a single hour, localized over a tiny area of just 20 to 30 square kilometers. It is hyperlocal and hyper-intense. To really put that staggering volume of water into perspective, let's think about the city of Indore. Indore gets about 1,062 millimeters, so roughly 106 centimeters of rain over an entire year on average. Now, a cloudburst drops 10 centimeters in just 1 hour. That means a single cloudburst is dumping nearly 10% of a city's entire annual rainfall in 60 minutes. I mean, the ground simply cannot absorb that much water that fast. The result? Instant, voluminous flooding. Now, what's really interesting here is that scientists are actually pushing for a new category, the mini cloudburst. While your standard cloudburst hits that 10 centimeters per hour mark, a mini cloudburst is classified at 5 centimeters of rain in an hour over that same small area. And honestly, depending on the local topography, even at half the volume, a mini cloudburst can be just as devastating. Section 2, anatomy of a cloudburst. So how exactly does all that water gather and just drop at once? Well, it happens in a pretty wild sequence. First up, warm, moist air rises rapidly into the atmosphere. Second, in mountainous areas, this gets supercharged by something called orographic lifting. Basically, monsoon winds violently smash into steep mountain slopes and get forced upwards. Third, as that air cools and condenses, it builds these massive cumulonimbus clouds that can tower literally 15 kilometers into the sky. And inside those towering clouds, you've got intense thermodynamic updrafts acting like a giant invisible shelf. They are so incredibly strong they defy gravity, holding massive, heavy raindrops suspended way up high. Finally, the weight of the water simply becomes too great, or those updrafts suddenly weaken. And when that happens, all that suspended water just plummets down simultaneously. Experts describe it like a literal ocean dropping onto the ground. Section 3, the forecasting challenge. Now, with global warming allowing the atmosphere to hold more moisture, these events are definitely becoming more frequent. But here's the crazy part. Predicting exactly when and where they're going to strike remains one of the toughest jobs in meteorology. Why? It all comes down to how weather models actually work. These models look at the atmosphere as a grid, estimating the average weather for each cell. Now, large-scale systems like cyclones or monsoons cover vast areas, right? We can track those for weeks. But cloudbursts? They develop incredibly fast and happen over an area much, much smaller than a standard grid cell. So, the crucial point is that they literally hide between the lines of our forecasting grids. Spotting them requires ultra-high-resolution models, and that takes immense computing power that often just isn't available. And it's not just a computing challenge. Mother Nature kind of fights back against our monitoring tech, too. Mountainous regions naturally have a high risk of cloudbursts, but that same rugged terrain physically blocks Doppler weather radar beams, creating these massive blind spots. Add in a severe lack of automatic weather stations up on the ground in those remote, high-altitude areas, and we're left flying blind. I mean, if there were no sensors to tell the computer what's happening right now, it definitely cannot reliably predict the next hour. All of this creates a staggering data gap. In Parliament, it was actually revealed that between 1970 and 2016, the IMD officially recorded only around 30 such incidents. Experts will tell you for sure that this is a massive underestimate. Why? Because if a cloudburst happens just a few kilometers away from one of those sparse monitoring stations, it might never be officially recorded as one, even if it causes total destruction downstream. Section 4, Improving Future Predictions. So, what are we doing about it right now? Right now, our primary defense is a technology called nowcasting. Since we absolutely can't track cloudbursts weeks in advance, nowcasting focuses purely on the immediate term. It issues short-term weather alerts every few hours to warn communities of rapidly developing local storms. But to really close this gap, the government's new Mission Mossam is taking some pretty aggressive steps. They're actually planning to double the Doppler radar network, aiming to jump from the current 40 radars up to a target of 80. The whole goal here is to finally catch these hyperlocal events that have been slipping through the cracks. And alongside the hardware upgrades, Mission Mossam is bringing in artificial intelligence. AI is going to be leveraged to process this newly doubled, massive stream of high-resolution data to better predict these hyperlocal events. Now, even with the best tech, it remains a really difficult task, but these upgrades are an absolutely critical step forward. Section 5, the accountability blame game. Now, let's talk about a dangerous phenomenon that happens with scientific terminology: the illusion of knowledge. See, when officials or the media immediately label a heavy rainstorm a cloudburst, it perfectly frames the resulting tragedy as a singular, totally unforeseeable act of nature. But this label is often hijacked. It actually obscures accountability, distracting us from human negligence, poor planning, and adequate infrastructure. Take the Darli floods in Uttarakhand in 2025 as a perfect example of this. Initial reports immediately blamed a cloudburst. However, as one source notes, meteorological data later showed that the actual rate of rainfall was much lower than the threshold for a cloudburst. The disaster was initially written off as an act of God, but the hard data proved otherwise. So if the rain wasn't the actual culprit, what was? Well, the data points straight to human actions. We're talking illegal construction encroaching right onto natural riverbeds, rampant deforestation that completely stripped the soil of its ability to absorb water, and a total absence of drainage infrastructure along these so-called all-weather roads. When heavy rain hit those compromised areas, the water had literally nowhere to go but straight through the towns and villages. Honestly, if the cloudburst label had stuck, officials might have entirely avoided questions about why buildings were allowed in high-risk zones and why early warning systems failed. And that brings us to the core of our explainer today. We've talked about the 15-kilometer high clouds, the radar blind spots, and the data gaps. But the ultimate takeaway is this: the next time you hear about one of these tragic events on the news, ask yourself, when disaster strikes, is it truly an unforeseeable cloudburst, or are we simply using the weather to mask our own poor planning and crumbling infrastructure? Thanks so much for joining me on this deep dive, and keep asking those tough questions.